Okay, we're in lesson 4.8, day 1. It's a 2-day lesson at least. And our little warm-up here is we want to complete the square to write the function in vertex form, identify the vertex. We don't have to go through all the steps of graphing. You'll get plenty of practice on your homework, don't you worry. So I said I would do number 1 with them as a little refresher, and then I'll let them try number 2. Okay, so first thing you do, group the x's. You can do it right in the equation if you want. Second thing, make sure I have a 1 in front of the x squared. Do I have a 1 in front?
Nope.
No, I have a -1, so I got to factor that out.
Yeah.
Which would give me a positive x squared and a positive 2x. Leave a gap. Okay, because you're just dividing it out. That's what factoring is. All right, then we complete the square. Ooh, number 2, there's lots of fractions. It's okay, you guys got it. Complete the square, so half of 2 is 1. 1 squared is 1. So 1 is what I'm going to add to make this a perfect square trinomial. Now, folks, here's the part where you got to be careful. What did I really add in my equation?
A -1.
I really did add a -1. You got to check that number out here and multiply them together and say, oh, I really did add a -1. So to counterbalance it, what do I have to do?
Minus 1.
No,
That
you
means
add
subtracting
1.
2.
You have to
What?
Add 1, right?
It's the
You
opposite.
added a -1, so if you add another -1, now you add a -2.
Okay. Now you're confusing us.
Well,
Why can't you just have it as
It's the
plus
opposite.
one?
Technically
Leave it like
subtracted
that.
1.
Yeah.
So don't you need to subtract 1 on the other side?
we did subtract 1.
Yeah.
So if we subtract 1 again, we're subtracting 2.
Like,
But you're subtracting 2 for both the same, like both sides.
If you add
Not
1
this
to
side.
the same side and you subtract 1.
You got to do the opposite, folks, so it's total 0.
Oh.
If you want it, okay, remember how we added it to the other side last time? You can do that. You can add, okay, so we added a -1. You can add a -1 to this side, and then you're going to add it over, and you're going to get +1. So you're just making more steps for yourself. But if you're writing in vertex form, you're just doing it to the same side to save yourself some time. Okay, that's all right. That's why we're practicing. So now this factors into x plus 1 squared. All right, I have a -1 out front. I'd probably just write it like that. And then I have a +3. Okay, there's vertex form. So what would my vertex be?
-1, 3.
Perfect. -1, 3. Okay. You don't have to write this down. Let me just quick explain why we can do this. So everybody was okay until we got to here. Okay. Everybody understands that I'm really adding a -1, right?
Yeah.
What's -1 times 1, Sydney? Okay, so you just added -1 to that side.
But you added 1.
But there's a number out here, so I really added a -1.
So you multiply the x and 2 by -1.
Yes, because I factored. That's how I started. That's how I started it.
Yeah.
Wait. You have to have a 1.
we just do +1 still, right?
Okay,
We just don't have.
So
form
here's
with
the thing.
complex form.
you added, technically on this side, you added a -1. So you can either do it to the other side, the same thing, to balance it, or you can just undo that by adding 1. Either way, when you go to put this in vertex form, you'd have to move this back over, you'd be adding 1. It's the same math.
So why, if you're adding 1 to the equation, how come you're not minusing 1 from?
You're not adding 1, you're adding -1.
So then it would be 2. It would be 2 up there.
What?
That 2 would be 1.
This 2's from here, sweetie. That 2's from that.
But then you still added 1 to it.
Right, because I have to undo it. I added -1 here. You got to keep the equation
-1
balanced.
plus 1 equals 0.
Hey, Justin.
Okay.
Here, she
Where the
subtracted
-1 comes from?
negative. She subtracted
The -1 came from
So we just.
you multiply
Yeah.
-1
Okay.
times.
You guys are making
-1
this harder than
to
it
make
is.
How about this?
Let me start with something basic.
In the
I
front.
get it. I just. It's confused.
So you
Okay.
have to get the -1 that you added.
Here's my equation. Here's an equation. Y equals x. Okay? if I add 1 to this side, is my equation still balanced?
No.
No, I gotta do the opposite. I gotta subtract 1. Or, because what's 1 minus 1? 0. So I would still get y equals x, right? That's all we're doing there, folks.
Well, no, I know, but
I'm adding in a -1.
So you're
then why can't
subtracting.
you just put negative 1?
Adding a -1 is the same as subtracting 1. Yes.
Why? How come you can't just put negative
Come
1 in the equation then?
Because
What?
-1 is -1, not 0.
No, okay, how come you can't put negative 1 on that plus 1 and then put the positive 1 on the 2? How come you have to put a positive 1?
Here?
And that, yeah, even though it's negative.
Because that's what this number is. That's how you complete the square. That's how you find that number to make this factor to that. That's how you complete the square.
Into the parentheses, the opposite too, Sydney. That might be
This, and remember when we completed square, I said this number is always going to be positive because after you square something, it's always going to be positive. You just have to check, did I really add in something else if there's a number out here that I factored out in the first step?
So wait, Sydney, what you're saying is why don't you subtract 1 from 2, right? That's what you're saying?
No, why don't you subtract?
She was in here.
Oh, okay.
Because this is always this number. If it was this number that we factored out, like let's say we factored out a 2, and I added in a 1. Okay, what did I really add in?
2.
2, so I'd have to
Then
subtract 2.
why don't you also multiply the x squared and the 2x?
We factor that out because there has to be 1 in front.
Okay.
That's the only way this process works, so we can get something like this to factor. Yes. What's 2 times 1, Kayla?
2?
So you just added 2. How do you undo adding 2?
Just distribute it, right?
Yes, 2 times 1.
Why are we adding it for just like multiple? Okay, well, let's just move on.
Yeah, I don't know how else to explain it. Sorry. You can ask somebody else. Okay, let's try another one. Maybe you'll see it with this one. And you'll practice them on your homework too. It's the same thing as completing the square. It's just you're adding it to the same side instead of the opposite side. Okay, so first step. Group the x's. Do I have a 1 in front?
No.
Okay, so I need to factor out the -2. Now, when I factor something out, I'm dividing it out. So here I'd be left with -7/2 x. Leave yourself a big gap. Leave that 12 out here. All right, so this is one's just a little bit trickier because we have fractions, but the process is still the same. So I'm going to take half of b. I'll come over here. Half of -7/2. And again, this only works if there's a 1 in front. That's why we had to factor that out. Which is -7/4. And if I square that, I'm going to get a positive 49/16. 49/16. So I'm going to add 49/16 right here. Okay, that makes this a perfect square trinomial. So what I really added in though was -2 times that. Because there's a number out there. So we can't just like ignore it that we factored out that -2. So I have to do the opposite. I have to counterbalance it. Let me just move my +12 over here. By adding, let's see, that'd be 49/8. Yep. Now the equation's balanced. All right, then this factors to a perfect square trinomial. Perfect square trinomial. X minus, you gotta do half of this term, 7/4 squared. Okay, I'll tell you what this is. When I add these together, I got 145/8, and you can do that in your calculator, or you can do common denominators if you want. So there's my final answer. In a vertex form. Just not pretty numbers. So that's okay. So we're doing one of these together. So what's my vertex?
7, 4, 145, 8.
This number, the opposite of that number, because that's just a shift to the right. 145 ace. Now, same kind of like rule, I would say, when you go to actually graph this, in order to plot that, like you can figure out what it is in decimals. Okay, and that's obviously going to be easier to plot. But anytime we're like writing our answers, we want to use exact. Okay, if that makes sense, good. If not, you have lots to practice on your homework. You just probably need to try some on your own until it clicks for you. Okay, whew, made it through there. So 4.8 is quadratic inequalities. So we're going to graph them and we're going to solve them. And we will probably just get to graphing today for the most part. There's one application problem. There's a couple on your homework, so I wanted to do one together with quadratics that we're going to solve by completing the square. Okay, so the value of John's stock portfolio is given by this function v of t, where v is the value of the portfolio in hundreds of dollars and t is the time in months. How much money did John start with? What is the minimum value of John's portfolio? Okay, this is kind of written in a weird order. You guys are used to seeing the quadratic term kind of written first. So I'm going to rewrite this. Like so. What form is this in?
Standard.
Standard form. Yep, standard form. What am I given in standard form?
1.
The y-intercept. So how much money did John start with when my time was 0 months? What's my y-intercept here? 50. Yep, but it's just in hundreds of thousands. Or not hundreds of thousands. Hundreds of dollars. So John started with $5,000. 50 times 100. Started with $5,000. That was nice in standard form. That was basically like given to me. That answers my first question. What is the minimum value of John's portfolio? All right, let's picture this on a graph for a second. What type of crowd will this be? Happy face or sad face?
That's
Happy face, positive leading coefficient. So if we were to graph it, it'd be kind of skinny. What point on here would be the minimum point? The vertex, right? The lowest point, the minimum point would be the vertex. So we're going to put this in vertex form to figure out what the vertex is. So that's kind of what we were just practicing. And with word problems, folks, we prefer decimals. Okay, we prefer decimals, so it's okay to have decimals here. I'm going to keep everything as fractions until like right at the end, I'll convert everything to decimals so we can kind of figure out, because my time in months and my money especially, decimals are preferred. Okay, here we go. One more time in the square. Let's do this. I'm going to do it over here. All right, first thing, group the t's. I'm going to have to factor out that 3, which would give me 77 thirds. Leave the big gap. Okay, so I'm going to take half of 77 thirds and square that, which is just 77 sixths. Do you guys know how to do this stuff in your calculator, or do you want me to show you? Like type this in your calculator and get an improper fraction?
Yeah.
This is what I got. I mean, basically, you just ended up squaring both the numerator and denominator there because it couldn't reduce at all. Anybody want me to show them on the calculator? Because I will if somebody needs it.
Why in the last problem did you not square the denominator?
I did when I added to both sides. Right here, 16ths.
Yeah.
But then when you go to factor it, is that what you're confused on? I added,
The 8.
I think I just wrote this wrong. This should be 16ths, sorry. I think I just maybe was looking at the wrong answer. Yeah, I was, sorry, that should have been. No, this is right, because we times it by 2.
And reduce. Yeah.
We times it by 2 and then I reduced it.
Oh.
Yeah, good thing I didn't try to fix that. Okay, yeah, that's why. Okay. So here, I have to add in this number. Okay, now, I'm going to do this part of my calculator. Make sure that I... Okay, we're good. Now, if I times that by 3, and again, you can do this all on your calculator, because that's what I really added in here, times that by 3, your calculator will give you that in an improper fraction, so I have to subtract that. 5,929 over 12. Over 9 over 12. Okay, that undoes it. So just do this number times this number and then do the opposite. Okay, now here's where I'm going to start converting everything to decimals, because this is going to make more sense with decimals. So I added these two numbers together. I added 50 to that. Let me do that again. 50 minus that answer. I got this. You got a different answer, really?
That's probably right in decimal.
Oh, okay. You wrote it correction.
Yes.
Okay. And now this number, 77 over 6 as a decimal is 12 point. Yep. Okay, so there we are in vertex form. This one was originally on your homework. I took it off so we could do it together. There we are in vertex form. So my vertex, if I want to find the minimum value, would I look at the x coordinate of my vertex or the y? Which?
Wow.
The y, right? That would tell me the lowest point. So my min is just the y value of my vertex. So you're like negative, and then in hundreds of dollars, times that by 100, we get this number. So that's my min. So he was obviously at a loss. Loss of money, John. Since we have negative. And that's the lowest value of his portfolio would reach. Whew, hopefully it bounces back up. That's what parabolas do, right?
Oh, it's a lot of money.
Mm-hmm. He probably needed to start at more than $5,000. Okay. So there's a couple like that on your homework where they ask you for like a max or a min, and just recognize, and I think we've talked about that before too. Max or min, you're just looking for the vertex, specifically the y value of the vertex. That's going to give you the highest or the lowest points. Okay, let's move on from this completing square. Let's complete the square stuff. So just to review, because we're still graphing here, we're going to graph inequalities, which we've graphed inequalities before, but they're going to be quadratic. Vertex form looks like this. We have some a factor x minus h squared plus k, where hk is my vertex. Standard form looks something like this, where I have an x squared term, some a value in front of the x squared term, some b value in front of the x term, oh my gosh, and some constant. That says plus. Okay, and then that factored form, we're just going to look at one, because this doesn't come up a whole lot in this class. We're just going to look at one. Because we have some a value in front, x minus p, x minus q, where p and q are my x-intercepts. Okay, so there's kind of like a couple ways you could graph in factored form. You could if you wanted to. Some people just like multiply this out, and then it's in standard form. You could do that. But there's actually like an easy way to graph factored form. We're going to do one together because you're given your x-intercepts. Okay, so here's my equation. So that's that factored form. It's still a quadratic because if I were to multiply it out, I'd get this. Okay, I'd multiply these two together. Obviously, I'm going to get an x squared term, then I'd have to distribute in a negative. So it's the same as this in standard form. Now, if we were given it standard form, we'd probably complete the square to write in vertex form to graph it, okay? But if I was given in this factored form, I'm actually given 2 points on my graph. I'm given the x-intercepts. So, factored form, I'm given, technically, the x-intercepts. Because the x-intercepts are when y equals 0, right? So let's plug in 0 here. It's already factored for us. This negative 1 out in front doesn't do anything. I can divide both sides by negative 1 if I wanted to. But normally if we were to solve this, we'd set each factor equal to 0. So we get x-intercepts of 5. And negative 1. Boom. We already have 2 points on our parabola, even though it's not our vertex. It's still pretty important points. Half the time when we're in vertex form, not half the time, 99% of the time when we're in vertex form, we find the x-intercepts anyways. So here's what you're given in that factored form. Okay, now here's that relationship I've been telling you with the x-intercept, is that your vertex is always halfway between these. Now before I go any further, would it make sense to get a vertex that's like above these points or below? What do we think? Below?
Wait, no, above.
Above it's negative. Because it's you guys.
Why?
It's a sad face.
It is a sad face. Look at my number in front here. It is a sad face, so it would make sense that I get my vertex somewhere up here. It's going to be a sad face. Good job. Good pattern recognition. All right, so my vertex is exactly halfway between these. So there's that little formula we put in our notes last time. P plus Q over 2, which just basically allows us to find halfway between these. But I know a lot of you could figure out what's halfway between negative 1 and positive 5. 2. So my axis of symmetry is at x equals 2. And the nice thing is you can draw that in if you want and like visualize it. Yup, that is right halfway between my x-intercepts. So then my vertex, what's going to be the x coordinate of my vertex? 2 something, right? 2 something. It's got to be on my axis of symmetry. Whoops. So from here, the only way you can find the other point is just by plugging it into your equation here. So let's do that down here. We can do this in our head. We end up getting negative 1 times negative 3 times positive 3. Gives us positive 9, which makes sense because we knew it should be somewhere up here. And there you go. We can graph it now. My parabolas are not the best. I actually think, vertex form is nice because you're given the vertex, but factored form is really nice because you're given the x-intercepts, and then your vertex is just halfway between it. Okay. That's that third form that we haven't looked at any examples. I don't think there's any of that on your homework. We got 4 minutes. Okay, we can at least start the next problem here. So this time you're given the graph and they want you to write the equation. So the easiest way to do this is to start in vertex form. Which is this. Y equals A x minus h squared plus k. There's my vertex form. It's kind of like, like point slope form of a line. Vertex form of a parabola. Do I know my vertex by looking at this parabola?
Mm-hmm.
Yeah, they're showing this to me. -3, 6. What letters in this little formula are my vertex?
Not H.
H and K. H and K. So we're going to plug 6 in for K, positive 6. I'm going to plug -3 in for H, so that would become minus -3 plus 3, yup. I don't know what A is, but I do know it should be what? Positive or negative?
Positive.
Negative. It's a sad face, right? So we actually have to solve for A. We don't know what it is. Could this be stretched out a little bit? It looks a little wider than a normal parabola. We don't know what it is, but what we're going to do is we're just going to plug in another one of these points. I just picked this point. Plug it in for X and Y. X and Y in here, and then we can solve for A. All right, so X, if I pick that point, you can pick that point if you want, is -5. Y is 4. So your first step, start in vertex form, solve, find A. Solve for A. Okay, to do this, first, order of operations, I got to start within the parentheses and add those. That would be -2. Next, exponents. What's -2 squared? 4 or -4? Positive 4. I'm going to write the 4 in front of the A because that's typically how we write coefficients. Okay, then I just got a -6. I get -2. Divide by 4. We get A is -1/2. That makes sense for 2 reasons. One, we knew it should be negative, and it's Y. Yup. All right, so to write this in vertex form, we'll stop here, but we're not done. To write it in vertex form, we just plug in that value for A, plug in our vertex, and just like always, you leave X and Y. So that right there, folks, that's vertex form. But the directions say to write it in standard form. Standard form. So we'll tackle that tomorrow.
Are you doing homework?
Okay, yeah, I can pass it out. Let me pause this quick. Well, I said I can pass out the 4, 8, 1 each. He's probably done with all the 4, 7.